Okay, so the basic instruction to compute the inverse function is this formula: y equal to f inverse of x if and only if x equal to f y y. So you use this formula and then you try to solve for y. After that, you get the inverse function. So a very important example of an inverse function, beside these examples, a very typical example is exponential logarithm. So that means if f of x is a to the power x, then f inverse of x, because remember, if f of x equal to a to the power x, so that means f inverse of x is log x with base a. So these are inverse of each other. Now, what happens if you come? Maybe I haven't told you. Have you heard about compositions of functions like FOG? Grade 11? Okay, never mind. So I will tell you later. Okay, so that was the inverse idea of the inverse. Now let's go back to some of this. Do you have any problems with solving this logarithmic equations? Is that clear? At least the logarithmic equations. Question 1, AB. Misran, do you have any question for problem 1?
Not yet.
Okay. Very good. So remember that, just let me give you one more example of a logarithmic equation. So remember that if you want to solve a logarithmic equation like log x with base 2 equal to like 5, then that means x is 2 to the power 5, which is 32. Now, what if we have log x, or let's say log of 2x minus 1 equal to 1. So if you have double logs, what you can do? So what you can do is, if log, let's say that this second log, let's say that this guy is t. Let's say that this is t. So we change a variable. So just for simplification. So when I say, so here basically the equation is log of t equal to 1, right? So when I say log of t equal to 1, that means t is equal to what? 2 to the power 1. So that means t is equal to 2. Now what is t? T is just another log. Right? Now we have to repeat this again. When I say log of 2x minus 1 equal to 2, that means 2x minus 1 equal to 2 squared, which is 4. So that means 2x equal to 5. Therefore, x equal to 5 over 2. Okay. Now, a very important, maybe the most important exponential function is the function e to the x. So this is the most important exponential function is f of x equal to e to the power x. Now, what is e? E is a number. So e is it's an irrational number. So e is some irrational number around 2.7. So the exact value, more precisely, e equal to the limit of 1 plus 1 over n to the power n goes to infinity. But don't worry about this limit, the definition of e. This is just the definition of e. So what you should know is e is a rational number, irrational number, sorry. It's irrational, it's around 2.7. And this is the exact definition if you want. It's the limit of 1 plus 1 over n to the power n goes to infinity. So it's, I mean, it is good. So try to compute this limit for big values of n. So for example, compute 1 over 100 to power 100. Use your computer later. You can use, like, for example, Excel. You can use an Excel sheet, give this formula. It's very easy. And it's good for you. You want to master Excel. Okay. Use a formula and then compute this 1 plus 1 over n to the power n for different values of n. I mean, the large values of n. Okay. And you see it's around 2.7, the result. Anyway, so instead of saying f of x equal to 2 to the power x, now we have e to the power x. This is super important in math, e to the power x. So the graph is similar to 2 to the power x, more or less. So the graph is more or less similar. So the y-intercept is 1. Maybe it's... So the y-intercept is y equal to 1. So there is a horizontal asymptote because the limit of e to the power x as x goes to minus infinity is 0, like 2 to the power x. So y equal to y equal to 0 is a horizontal asymptote. Now, once you have e to the power x, we can do different transformation on this. Like we can draw e to the power minus x. Let's draw e to the power minus x. Or minus e to the power x. So e to the power minus x, you just flip it around the y-axis. But What about minus e to the power x? How does minus e to the power x look like? Reflection around the x-axis. So if you want to draw, so this at the bottom is e to the power minus x. But if you want to draw minus e to the power x, it's like this red graph. So this red line is minus. So y equal to minus e to the power x. So similar to exponential and logarithm, we also have the inverse of e to the power x, which is another logarithm with base e. So inverse of f of x equal to e to the power x is, so when I say y equal to e to the power x, it means that x equal to log of y with base e. But remember, log with base e is called natural logarithm. So this log with base e is called the natural logarithm. And we have special symbol for natural logarithm. We usually write ln for natural logarithm. ln to denote log e, the natural logarithm. Okay, therefore, when I say y equal to e to the power x, if and only if x equal to ln of y. So basically, ln means logarithm with base e. It is the natural logarithm. Okay, so now what is ln of 1? Like all other logarithm, ln of 1 is also 0. I mean, log of 1 is always 0, basically. What is ln of e? 1, because e to the power 1 is e. And similarly, like ln of e squared is 2, obviously, and so on. If you want to draw the graph of ln, this is y equal to ln of x. The x-intercept is x equal to 1. Now, what is the domain of ln? It's similar to all the logarithms. So the domain of ln is positive number. So if f of x for f of x equal to ln of x. So the domain of f is the set of real numbers, positive, which is in the interval notation, is the interval of 0 to infinity. So the range of f is all real numbers. And by the way, I didn't mention this, but it's, as I said, it's similar to all x, like 2 to the power x. So the domain of e to the power x is all real numbers. The range of e to the power x is positive numbers, right? So if you have f of x, let me just quickly write it here. F of x equal to e to the power x. The domain of f consists of all real numbers, and the range are positive numbers.
The opposite. Range is all real numbers.
Now for e to the power x, the domain is all real numbers, range is positive numbers. Now you switch range and domain of e to the power x, you flip it, you get the range and domain of ln. So for ln, the domain is the positive number, the range is all the real numbers. So, and there is a vertical asymptote, x equal to 0, because since the limit of ln of x as x goes to 0 plus is minus infinity, hence you have a vertical asymptote. X equal to 0 is a vertical asymptote. So now if I give you other, like more complex ln function, so for example, I can give you f of x equal to ln of x minus 1. So I can ask like similar questions. What is the domain of this function? What is the range? What is the vertical asymptote, if there is any, and so on, right? So for instance, what is the vertical asymptote for this one? X equal to 1 is a vertical asymptote. Horizontal, not for ln, but for e to the power x, there is a horizontal asymptote. Or e to the power negative x. So that, and the horizontal asymptote for e to the power x is y equal to 0. But if you have something like f of x equal to e to the power x plus 5, now the horizontal asymptote is y equal to, because the limit of f of x, x goes to minus infinity, is equal to the limit of e to the x plus 5, x goes to minus infinity. Remember that e to the power in minus infinity is 0. So e to the power x plus 5 as x goes to minus infinity is just 5. Now the horizontal asymptote is y equal to 5. So y equal to 5 is the horizontal asymptote.
So the vertical is just 5, right?
No, there is no vertical here. Horizontal asymptote. For exponential functions, you have horizontal asymptote. For logarithm, you have vertical.
So why is just the last number, right? That's why I said 5 is the bottom.
Yeah, so you can also draw, that's a good question. You can draw the graph. So e to the power x plus 5. So first of all, y equal to 5. Let's say that this is y equal to 5, this line. So this is y equal to 5. This is a horizontal asymptote. And the function f approaches this line as x goes to negative infinity. So the graph is something like this. Or you can say you just do a vertical translation of 5 units upward. Okay, so now recall we have the same property for ln as we had for logs. So recall that. Recall. Like ln of a plus ln of b equal to ln of ab. Ln of a minus ln of b is ln of a over b. Ln of x to the power r is equal to r ln of x. In particular, ln of 1 over x is minus ln of x. Now I want to add one more rule, that is log of a with base b equal to ln of a divided by ln of b. Or you can also say, or more generally, log of a with base b is any log of a with base c. You can have any base. So in the formula, on the formula 5, so the base is e. But here you can use any other base that you want. So log of a with base b is log of a with base c divided by log of b with base c. In particular, if c is equal to e, then you have log of a with base b equal to ln of a divided by ln of b. Okay, now let me give you some example of exponential equation. So I want to solve for x. So remember that when I say like e to the power p is equal to q, this is equivalent to saying that p equal to ln of q. Because these are inverse of each other. This is very important. E to the power x and ln of x are inverse of each other. So when I say e to the power p is equal to q, that means p is ln of q. Right? Now let's do this equation. E to the power 5x equal to 3. That means 5x minus 1 equal to ln of 3. And in your calculator, you can also see ln and e to the power x in your calculator. Okay, so what is x then? So 5x minus 1 is equal to ln of 3. Then 5x equal to ln of 3 plus 1. So x equal to 1 over 5 times ln of 3 plus 1. If you want the numeric values of this, like in decimals, you can use your calculators. So for example, let me use my calculator. So what is ln of 3 plus 1 divided by 5? So this number is around 0.42. I give you another equation. Let's say that e to the power 2x plus e to the power x minus 1 equal to 0. How you can solve this now? Yes.
You could like substitute e of x in the variable and solve it for that.
Exactly. God bless you. Let e to the power x be t. So that means e to the power 2x is just t squared, right? So that means that in your equation, you just have t squared plus t minus 1 equal to 0. Now you have a quadratic, as you said. Now you can solve this quadratic, right? What is the solution? So t is minus 1. There are two solutions. One is t equal to, so two solutions of the quadratic. One is t equal to minus 1 plus square root of 5 divided by 2. The other one is t equal to minus 1 minus a square root of 5 divided by 2. But you have to be careful because the second solution is a negative number. So this is negative. But e to the power x cannot be negative. So you cannot accept this because e to the power x, which is equal to t, must be positive. So that means we have to reject the second solution, but we can accept the first solution, which is t. But remember that t is e to the power x, right? So e to the power x, t is equal to e to the power x, which is equal to -1 plus the square root of 5 divided by. Now, what is x? When I say e to the power x is this, x is what? ln of this guy. Again, because here, these numbers are irrational. All of these numbers are irrational numbers. But you can use your calculator to find an estimate of this number. So for example, here, what is -1 plus square root of 5 divided by 2 and then take the ln. So this is a number around minus 0.48. Okay. Yeah. Okay, so any questions so far? So some remark, remark is that ln or so this is similar for other logs, basically if the base is greater than 1. So ln of x is positive if x is greater than 1, and ln of x is negative if x is between 0 and 1. And ln of x is 0, of course, if x is equal to 1. And you can see this from the graph of the function ln. You see, for x equal to 1, it's 0. X greater than 1 is positive, right? Here is positive. X less than 1, it's negative. for example, if someone wants you, example, solve the inequality. Let me tell you something easier, but then. So when I say ln of 5x minus 1 greater than 0, it means, based on what I just said, it means that 5x minus 1 must be greater than 1. That means 5x must be greater than 2. Therefore, x must be greater than 2 over 5. Now, what if I say ln of x squared minus 3x? Zero. So, ln of x squared minus 3x positive. So that means x squared minus 3x must be greater than 1. So x squared minus 3x minus 1 must be positive. So again, here you have a quadratic. What are the roots of these quadratics? So the roots of this is a quadratic. So the roots are x equal to 3 plus or minus the square root of 9 plus 4 is 13 over 2. You see that there are two roots. One is 3 minus the square root of 13 divided by 2. The other is 3 plus the square root of 13 divided by 2. So this guy is negative between the two roots, positive here. So what I'm looking for is the positive solutions. That means it should be this region and this region, right? So that means x must be either greater than 3 plus the square root of 13 half, or x less than 3 minus the square root of 13. Okay. Is that clear? Any questions so far? Okay, so some applications, let me tell you some applications of exponential and logarithms. So one important application is logarithmic scales. For some quantities like intensity of earthquake or acidity of materials, pH, we can use logarithm because we deal with large numbers. When we deal with large numbers, we can use logarithmic scale to reduce the number, to make it easier to work with, basically. So one example is Richter scale for earthquakes. So the magnitude of M, the magnitude of the earthquake is equal to, or maybe I can say, if you have two earthquakes with magnitudes M1 and M2, the difference in the magnitudes is equal to log of I1 over I2. So M, the magnitude of an earthquake and I, intensity. So you have M equal to log of I. So for example, if, I don't know, if the magnitude of one earthquake is 7 and the other one is 3, so how much more intense is the first earthquake comparing to the second one? No, I'm talking about intensity. So remember that if M1, for example, equal to 7, M2 equal to 3, so you have 7 minus 3, which is 4, equal to log of I1 over I2, right? Now, when I say, so the left-hand side is 4. So that means I1 divided by I2 must be equal to what? 10? 10,000, 10 to the power 4, basically. Oh, because when I say log of something is equal to 4, oh, this is log with base 10, but by the way. This is log with base 10. Yeah, I forgot to say. But usually when we don't write anything for log, it's log with base 10. But for in actual math, in professional math, the only log is ln. ln, the natural logarithm. So in math, you basically write anything in terms of ln. Because that's the natural logarithm, it's natural. Anyway, so but when usually in textbook, in high school, when you don't write anything, it means 10. In more advanced text, when you don't write anything, it means ln. Right? Okay. So when I say, okay, go back to your question. When I say log of something is equal to 4, this is with base 10, right? Log of something with base 10 equal to 4. That means this thing, I1 over I2 is 10 to the power 4, right? Which is 10,000. So now you see the difference between intensity of these two earthquakes with magnitude of 7 and 3 is 10,000. So one is 10,000 more intense than the other one. So basically here, you can say that from this equation, it follows that I1 over I2 is 10 to the power m1 minus m2. So you use the same thing, logarithmic scale, for pH scale, acidity or alkalinity. So let me draw it. So it's like intensity versus the magnitude. So here I put, so these are the pH scales. Like 0. These are like magnitudes of the pH. 0, 1. And the intensity is like 10 to the power 0, 10 to the power 1, 10 squared, 10 cubed, and so on. Oh, sorry. So the only thing, I'm sorry, my mistake. So these are the pH are negative values. So this is 10 to the power negative 1, 10 to the power negative 2. So pH 7 is the water. And less than 7, so here pH greater than 7 is the alkaline. pH less than 7. Oh, sorry, then less than 7. 7 is the pure water. Another example is for the sounds, we use decibel. For the intensity of sound. So in the intensity of sounds, like I1, let me write the formula. So here dB means decibel. Decibel is a unit for the intensity of sound. So in other words, you can say basically dB1 minus dB2 over 10 is equal to log of I1 over I2. Okay, so these are some examples of logarithmic scales for different quantities. Now, the most important application of exponential and logarithm is the exponential and growth or decay. So if you have some quantity, it's like a population, for example. Population, then we say it's in exponential growth or decay if it's like P0 times e to the power kt. So what is P0? P0 is the initial population and K is the factor of growth or decay. So for example, we know that if K is positive, then you have growth. If K is negative, then you have decay. Okay. Let me give you an example. So the example is the following. Imagine, suppose that the half-life of some radioactive material is 2 minutes. So the half-life is 2 minutes. If the initial amount is like 500 grams, then write an equation for the decay. So I want to write equation because here we haven't right. Generally, if you have a radioactive material, they decay. So now it says that the half-life is 2 minutes. So there are two ways to do this. So let me do it in two ways. So I can tell you two solutions. So the half-life, we know that the half-life is 2 minutes. So first of all, the only equation that I have for the decay is P, or you can say empty for the mass. Usually for population, we use P, or for the mass, you can use M, but that's fine. This is just some letters. So P denotes the mass at time T equal to P0, the initial mass, time, which is 500 grams, by the way. So here, let me just write first this. So P0 is 500 grams. Now the half-life is 2 minutes. That means P of 2 is equal to 1/2 of P0, right? The half-life is 2 minutes. So here T, the unit of T is the minutes. So P of 2 is 1/2 of P0. So if you plug in to this equation, to the original equation, so what is the equation that I have? Equation for P is P is equal to 500 e to the power KT. Now, P of 2 is 1/2 of P0. What is P of 2? P of 2 is 500 e to the power 2K. Because here I want to find K, the decay factor. And this must be equal to 1/2 P0, which is 1/2 500. So from this equation, it follows that e to the power 2K must be 1/2. Right? So that means 2K is ln of 1/2. So that means K is 1/2 of ln of 1/2. So by the way, ln of 1/2, let me just write here. ln of 1/2 is minus ln of 2. You agree? Remember from the properties of logarithm? ln of 1/2 is minus ln of 2. So 2k is minus ln of 2. So that means k is minus 1/2 of ln of 2. Therefore, that is k. Now we know that the equation for the decay is 500 e to the power minus 1/2 ln of 2 times t. Can you simplify this number e to the power minus ln of 2? Minus ln of 2 is a number, right? But you can also simplify e to the power minus ln of 2. This is the answer. We are done now. But just, it's good if we can write a more simple equation for my answer. But basically, I'm done here. Now the question is, what is, can we simplify? Can you simplify e to the power minus 1/2 ln of 2? Or something here that I didn't tell you, but I'm going to tell you about the composition of two functions is that e to the power ln of x equal to x. So when you compose a function with its inverse, you get x. And ln of e to the power x is also x. Basically, once you, because when you do inverse, you switch x and y, right? Once you do it twice, you get to the original position. So e to the power ln of x is equal to x. Now I want to compute e to the power minus 1/2 ln of 2. So e to the power minus, so first of all, minus 1/2 ln of 2 is equal to 1/2 ln of 1/2, which is ln of square root of 1/2, right? So e to the power minus 1/2 ln 2 is e to the power ln of the square root of 1/2. And as I said, e to the power ln of x is x, so this is just square root of 1/2. Now, e to the power that is just square root of 1/2. So that means I can also say this is square root of 1/2. So I can also say pt is equal to 500 times square root of 1/2 to the power t, which is the same as 500 times 1/2 to the power t half. So now this is something I like, simple. 500 times 1/2 to, this is but power, be careful, it's not multiplication. Let me write it on the top.
actually be able to solve this kind of question on test, right?
Don't worry. So because
Is this extra or?
I began this new unit this week, so next week I'm going to do more problems for this unit, but it's not in your test. So the test on Tuesday is only for unit 1, which is polynomials, domain, range, those topics, okay? So after the lunch, you come back around, because I have the class with grade 11 guys.